Okay, this is geometry test, and we are on chapter 10.1 through chapter 10.4. This test will consist of 3 sections. Section 1 will be questions about a circle diagram, where I will have a diagram of a circle on there, and you will have to list parts or identify parts of the circle. Then you'll have multiple choice questions about circle vocabulary, such as diameter, radius, chord, tangent, secant, things of that nature, and then problems. I'm going to go through now and give you some examples to look at. I would look at, for instance, as far as the diagram of a circle, that's a pretty good one from your textbook, is down at the bottom of page 599, the matching section down here that talks about chords, centers, and other such things as that, vocabulary of your circle. Also, the problems that I would really look at using would come from also page 601. The problems 46 and 47 are very good problems. Those two are lines that are tangent from an external point. You set those equal 2x plus 7 equals 5x minus 8. Not 47, excuse me, just 46 would be the problem I would learn from that we did in class. You'll know most of your highlighted vocabulary from these sections. You will do extremely well on the vocab part of the test. I would also look at problems on page 608. If you look on page 608, problems such as number 36, 37, and 38. On 36, what we need to do there is know that if we give you a diagram on a circle, a diameter, excuse me, we want you to use that diameter. You would say 2x minus 30 plus x equals 180 and solve for x. On this number 37, if you could somehow or another look past that and block that out, say 4x plus x equals 180 and solve for x, that would help you solving that one. In 38, if you could say 4x plus 6x plus 7x plus 7x equals 360, you would accomplish solving for x on that. Know that all the arcs of a circle are 360. So most of the things tomorrow on the test, you're either going to set equal to 180, add up to be 180, or use 360 if we're talking about the arc. Remember that if an angle is a central angle, such as on number 32, find it right there, this arc measures 70 degrees, therefore the angle ADE is also 70 degrees. Central angles share the same degrees as the arc that they intercept. Alright, flipping the page over, looking on inscribed angles. These are angles whose vertex are actually on the circle. For instance, this angle is an inscribed angle because its vertex is on the circle. Therefore, the angle is exactly 1/2 the measure of the arc that it intercepts. Some example of problems would be like down here, where we would find that, for instance, the measure of this arc NE right here is 100, so this angle is 50. It's half of that. This angle measures 115. If we double it, it's 230. We find the measure of the major arc. This arc angle is 90, so we find the measure of that arc to be 180, which is a semicircle. So if it's an inscribed angle, if you're looking for the angle, divide the arc in half. If you're looking for the arc, times the angle times 2. Also, if we have a polygon such as B right here, if it is inscribed in a circle, that means all the vertexes or vertices of the polygon are on the circle, then the angles opposite are supplementary. Therefore, x would be equal to 100 and y would be equal to 60, because 180 minus 120 is 60 and 180 minus 80 is 100. So if you see a polygon, know that opposite angles are supplementary. Up here at the top, I'm on page 617 now. When you're looking at these two different types of problems, in this one we're looking for the arc. 32 is the angle. It's inscribed, so double it to 64. this problem, they give us the arc, which is 110, divide it by 2, and we will find that the angle measures to be 55. Trying to see if there's anything else on those. Those we went over pretty well. And lastly, other angle relationships in circles is pretty easy. If you look, you've got lines that intersect. They're going to intersect with their relationship to a circle in one of three places. If they intersect on the inside of the circle, such as this one, then you add the two corresponding arcs together, divide by 2, and you would find that that angle there would measure 112.5 degrees. If they intersect on the outside of the circle, such as in number 20, subtract the arc 105 minus 51, and you find that to be 54. Divide that by 2, and that angle is 27 degrees. Now, if we have an arc such as, let me kick back over here to page 624. Let's look at number 2. This arc is 105. It's made up of a chord and a tangent. The point of tangency is S. We treat this angle just like we would an inscribed angle, where the angle is 105 degrees, and the measure of arc STU is double that, or 210. So you treat it just like you would an inscribed angle. The problems that we worked in class today that will be pretty beneficial for tomorrow are problems on page 625, number 26, number 27. This is pretty relatively easy. You just take half of 260, which is 130. 8a plus 10 equals 130, and solve for a. On this one, say 360 minus 255, that'll give you the measure of this arc right here, which will be 105. Say 255 minus 105, and that will give you 150. Cut that in half to 75, and 15a equals 75. That's really it for the test. A good mixed review would be down at the bottom of page 627. Looking at problems such as 49, 50, and 51, since those lines are tangent to the circle from the same exterior point, then they are congruent, set them equal. I guess for a bonus that I would really want to know on this type of problem would be, for instance, on page 621 down at the bottom. This will be your bonus, to where we have 5x and we have 9x plus 20. Now, 5x is the angle, so we know the arc is double that angle. So double 5x, as they've done here, to 10x, and say 10x equals 9x plus 20, and you solve for x, and you'll find that x equals 20. All you do is subtract 9x from both sides, and you're left with x equals 20, so 20 is the answer. And the bonus deals with you knowing that this is an arc made by a chord and a line that is tangent to it, so that it is half of the measure of the arc that it intercepts. Study 10.1 through 10.4, and I think that you will do just fine on the test tomorrow. Good luck, and hope that you all do well. See you tomorrow afternoon.